Hi everyone, in this video lesson I'm going to cover how to perform the independent samples means t-test on SPSS. I have the general social survey data open. Remember that for an independent samples means t-test, I have to have an independent variable that is nominal or ordinal, and I have to have a dependent variable that is interval ratio since we're comparing means. So for my independent variable, I've selected educational degree. And I'm going to predict that educational degree can determine the number of children that people have. So the two categories that I'm going to select for my test are going to be less than high school and bachelor's. And what we'll need to do is write down the codes for less than high school. So the code for less than high school is 0, and the code for bachelor's degree, and that code is 3. So I'm going to compare these two groups and see if it results in a mean difference in number of children. So to get started, I'm going to go ahead and click on Analyze, Compare Means, and select Independent Samples t-test. After doing so, I'm going to right-click on the list of variables and select Display Variable Names. I know that the variable name for educational degree is just degree, so I'm going to go ahead and locate that and place that into the grouping variable. Next, I'm going to click on Define Groups so I can tell SPSS which two groups I want to compare. Remember, we wrote down those codes for the individuals with a less than high school degree. They were coded as a 0, and individuals with a bachelor's degree who were coded as a 3. So now we're telling SPSS to compare the group coded as a 0, less than high school, and the group coded as a 3, a bachelor's degree. We click Continue, and now we're going to pick our independent variable. So the dependent variable is number of children, and the variable name for that is child. So we're going to go ahead and move that over to the test variable box. We're just going to click OK and obtain our results. And so these are our results. And so what we're going to want to do is go ahead and open up a Word document. Right-click on the first table, Group Statistics, and select Copy Special. Then I'm going to uncheck everything except for Image, click OK, and copy it on over to my Word document. Next, I'm going to take the second table and do the exact same thing. Right-click, uncheck all, select Copy Special, uncheck all of the boxes except for Image, and go ahead and copy that over to my Word document as well. Now I can just focus on my Word document itself here, and I'm going to go ahead and show you how to interpret this information. The thing I'm going to focus on is the second table when we go to write up our results, but it's also might be helpful to take a look at the group statistics. What the statistics tell us is that our sample consisted of 287 individuals with less than a high school degree, 354 respondents with a bachelor's degree. And so let's take a look at the averages. The average number of children for those with less than a high school degree was about 3, 2.95 to be exact. And the average number of children for those with a bachelor's degree was 1.5, 1.53 to be exact. So those with less than a high school degree had about twice as many kids than those with a bachelor's degree. And this is true for our sample. What the independent samples t-test is going to do is give us a hint as to whether or not this is true for the larger population. So let's go ahead and get started. First, let's take a look at the issue of equal variances. The first step is to decide whether we're going to look at the row with equal variances assumed or equal variances not assumed. Here's how you tell. There's something called the Levine's test for equality of variance, and we're going to look at the significance level for the Levine's test. If our significance level is less than 0.05, then we assume that variances are not equal. If we have a significance level that is higher than 0.05, then we assume that variances are equal. So basically, if the significance level for the Levine's test is less than 0.05, we use the bottom row. If it's greater than 0.05, we use the top row. So in this case, the significance level for Levine's test is 0.000. So that is indeed less than 0.05, and therefore we use the bottom row. So we're going to assume that variances are not equal and use that bottom row. So with that figured out, we can ignore the top row and just look at that bottom row. In that bottom row, we have a couple of really key pieces of information. First off, we have a t-statistic of 9.722. We have degrees of freedom of about 507. And here's where we determine whether or not we can accept or reject the null hypothesis in this column here with the significance two-tailed p-values. So the p-value is 0.000. So if our alpha was set at 0.05, this p-value is definitely less than our alpha of 0.05, and so therefore we would reject the null hypothesis. We also have a mean difference in the sample of 1.42. This means that in the sample, those with less than a high school degree had about 1.5 more kids than those with a bachelor's degree. And then we also have the 95% confidence interval of the difference. So basically what these two boxes tell us are that in the larger population, those with less than a high school degree could have as little as 1.1 more children than those with a bachelor's degree, or as many as 1.7 more children than those with a bachelor's degree. Either way, we're 95% certain that it's somewhere in between those two values. So all in all, we did find that number of children does vary by your educational status. So I'm going to go ahead and write up the results and then read them back so that you can have an example of how to write up your results for your activities. Okay, so I've written up my results, and the first thing we want to specify is whether or not our variances are equal. Based on the Levine's test, we found that we can assume they're not. Our significance level was less than 0.05 for the Levine's test, so that means that variances are not equal. So I start off by saying we assume that variances are not equal based on the Levine's test for equality of variances. Now we can start talking about the t-statistic and degrees of freedom, etc. So I start off by saying our t-statistic was 9.722 and our degrees of freedom was 506.936. The p-value associated with these numbers was 0.000. Therefore, we reject the null hypothesis and state that there is a mean difference in number of children between those with less than a high school degree and those with a bachelor's degree. We state our alpha in parentheses, and if our p-value is less than alpha, we write it out as such. P is less than 0.05. Lastly, the 95% confidence interval of the mean difference suggests that those with less than a high school degree have somewhere between 1.136 and 1.711 more children than those with a bachelor's degree. So use this example for your particular activity that you're going to perform yourself. And please let me know if you have any questions.